Guys, let's do this chapter 6, which is essentially multiple phases mass balancing, problem 38. A fuel gas containing methane and ethane, so there's a stream containing methane and ethane, is burned with air, so there's also air, which is oxygen and nitrogen, at 0.21 and 0.79%, with air in a furnace. So let me draw this furnace. Here's fire. Producing a stack of gas at 300 Celsius and 105 kilopascals absolute. The stack contains CO2 and the partial pressure of CO2 is about 80 millimeters of Hg, and no CO and no O2 and no methane and no ethane. So I'm supposing or guessing that the methanol plus the oxygen produce a CO2 plus H2O and the ethane also. So I'm going to suppose 100% combustion, and there's no excess of oxygen because they tell you there's no O2 going out. So I'm going to have water and nitrogen. So let me name this Y1, Y2, 1 minus Y1 minus Y3. No, Y2, sorry. What else do we need? Let's call this flow N0, which is the feed, N1, and N2. The first thing we need to do is choose a basis. I'm going to choose a basis of the product, 1 gram of product. Why? Because it's difficult here and I already have this. So you could choose either one, but I'm going to choose it here, 1 gram mole. So let me write the reactions. Methane plus 2 molecules of oxygen gas will form to give you CO2 plus 2 molecules of water. And for ethane, it's CH6 plus 7 halves O2 will react to give you 2 CO2 plus 3 H2O. We have our reactions. So let's start doing mass balancing. We know the mole fraction could be calculated from this partial pressure. So let's do it. Y of CO2 equals to the pressure of CO2 divided by the total pressure. This partial pressure is 80 millimeters of hydrogen, which is mercury, divided by P, which is 105 kilopascals. I don't want kilopascals, and I 101.3 kilopascals equal 760 millimeters of Hg. So doing this operation, I got this amount. This is my YCO2 at the end. So it's essentially Y1. Now, we're going to do mass balancing with reactions. Let's do mass balancing in the reactor or the furnace to get N1 and Y1 and everything what is left. So I'm going to suppose it's 100% combustion, so the total amount of moles at the end it's equal 1. Why? Because I told you so. N2 equals total amount of moles, and I choose it to be 1 as a basis, so that's my advantage. That's why I choose it. So let's do the first mass balance atomic species on carbon. So we have inlet equals outlet, because they are atoms, they don't create nor destroy. So it's 1 mole of, let's see what's the inlet. Inlet will be N0. Let's write our general formula. It's N0 plus N1 equals N2. Now, what two species in N0 do we have with carbon? We have methanol and ethanol. N1 we have oxygen and nitrogen. And N2 it's CO2 and water and nitrogen. So just know when do we need it. So we have 1 mole of carbon in the amount of moles of methanol. So it's N0 times X of, no, it's Y0. This is the amount of methanol plus the amount of moles in ethanol, which is 2 amount of moles, N0, 1 minus Y0. This is the mass balance or the atomic mass balance of ethanol. This equals the, what do we have? CO2. So the mass balance of CO2 we have N2, which is actually 1. So let me just write that. N2, it's 1 times Y1. So let me write this beautifully. It's N0, Y0 plus 2 times N0, 1 minus Y0 equals Y1. This is my first equation. Now let's do mass balance atomic on nitrogen. So it's 3 well, first of all, guys, it's time to put a number to this. So I will use N1 for oxygen and 3.75 times N1 and N1. Hopefully you relate to these numbers. This is the relationship between this. So I'm going to use N1 as my oxygen. So let's go here. Where are we? Yeah, here. So 3.76 times N1, which is the inlet of the nitrogen, equals the outlet, which is the mole fraction. We don't have it, but we can calculate it from this equation, times N2, which is 1. So 1 minus 1, okay, this value equals 3.76 N1. This is my second equation. Continue with the mass balance, atomic mass balance, and not nitrogen but hydrogen. We have 4 hydrogens in methane, N0, Y0, plus 6 hydrogens in ethane, which is 1 minus Y0 times N0, equals Y0 times N2, which is 1, and we have 2 hydrogens here, so it's 2 hydrogens. Why do we have only 2 hydrogens? Because H2O, or water, only has this. So let me write this a little bit better. Equals 2Y2. This is equation 3. And I still need one more equation so I can solve all this. We need the one of hydrogen. Now the one of oxygen. So it's 2 moles per N1, which is N1 is oxygen gas in the air. Y1, we need, how much do we have in N2? Let me see. N2 we have CO2. So let's account for 2 of CO2. Y1 times N2 plus 1 in hydrogen. No, 1 hydrogen in, where? No, 1 oxygen in water. 1 oxygen in water times Y2 times N2. So solving this, N1, this, 2, Y1 plus Y2. So from 1, 2, 3, 4, we got this. We got, what do we have? So we need N0, Y0, Y1, Y2, N1, N0, Y0, okay, Y2, and Y1, okay, yeah. So we have 5 equations. Probably we need to find out one value. I think I calculate Y, yeah, this here. This is actually Y1, so this one is not actually a variable. We have 4 equations with 4 variables, so we can solve it. So let me solve it. It's 2N1, 2Y1. This is my system. I'm just rewriting everything. So solving, I got this in my calculator. I'm kind of lazy, but I got N0 equals 0.077, N1 equals 0.1912. I got Y0 equals 0.6924, and Y2 equals 0.7093. and y0 will be 0.692. So let me see what we are doing. Calculate the mole fraction of methane in the field. That will be, I think, y0 here, 1 minus y0 in the field, and the dew point. So y0 is what we're asked for. This is our first value, and they tell you the temperature or dew point. So the vapor pressure equals 141 millimeters of mercury. Let me just double check that. Where is it? The double pressure. Okay, so when we have this, if you check in tables, you will find the temperature equals 59 to 60 Celsius. So that's the dew point, guys. So yeah, essentially was everything. It's kind of tricky at first because you have two equations here, but that's not the problem. The problem is to choose a correct basis. You could choose any basis you want, but this will simplify your calculations. And yeah, just find all the mass balances. I use atomic mass balancing, but you can use molecule mass balancing. I use a software to solve it, and I got the mole fraction they wanted me to get. So yeah, I think that's everything, guys. See you in the other video.